Microscopic Universe, the quantum playground of matter. This is the topic of discussion in today's lecture. So the topic is what? Microscopic Universe. Universe, we have idea about the universe. Okay. Here microscopic universe means it is the universe of the smallest particles like electrons, protons, neutrons, any other subatomic particles. Why this is studied separately? Because here the governing equations or the rules set by the science are different than classical physics. By using classical physics, we can predict many things. Almost everything which can be seen by our naked eyes. But the science of the smallest particles, I have already mentioned the particles like quarks, gluons, electrons, protons, neutrons, etc. The science of those things cannot be analyzed or their behavior cannot be predicted by using the laws of classical physics. Separate science is there, which is known as quantum mechanics. Yes, quantum mechanics, this dictates a different set of rules for the smallest particles. Their behavior can well be predicted by using this set of rules. The rules of quantum mechanics, right? So this is different. So what is the difference? Difference, I think you have idea. You have some idea about the difference. First difference, the principle of superposition. Any particle can exist in multiple of states at once. But in case of classical physics or in case of particles which are visible by our naked eyes, in those cases that is not true. In those cases any object exists in a single state. Any object exists in a single state, not multiple. But in case of smallest particles or subatomic particles, any particle can exist in multiple states at once or simultaneously. Means they are in superposition state. Okay, they are in a state of superposition. So this is the difference. Next difference is quantum entanglement. Yes, quantum entanglement, you know this thing. I think you know, it is known to you. Quantum entanglement means if two particles are entangled, then in that case changing the state of one particle immediately affects the state of the other particle, whatever be the distance between them. Even if the distance is in terms of light years, then also it is true. Whenever you are measuring the state of one particle, it immediately affects the state of the other. No time is elapsed between the occurrence of these two events. Okay, so that is known as quantum entanglement. Next is wave particle duality. Any particles, suppose electrons. Okay, electrons are known by all as particles, but these electrons can exhibit both the properties of particles as well as wave in different conditions. If these are observed or if are measured, then the behavior is somewhat else. And if not observed or not measured, then behavior is different. You know the example, double-slit experiment. Okay, when the observation is not made, the wave-like pattern is obtained on the screen, means interference pattern. That pattern is shown only by waves. Okay, that means wave-like behavior can be obtained when not observed, but when observed, only particle-like behaviors are obtained. Okay, so electrons are showing both particle as well as wave-like nature, which is known as dual nature of particle. Okay, wave particle duality. Not only electrons, if you take other particles, then also you will get the same result. Okay, so these are the differences. These things, these phenomena are not observed in case of classical physics or larger objects, larger than the subatomic particles. Okay, then there is one more thing, that is Casimir effect. You know that vacuum is empty. According to our knowledge, vacuum is empty. But in quantum mechanics, you see that vacuum is not empty actually. Vacuum, this is full of quantum fluctuations. Virtual particles are constantly popping in and popping out of existence. And they are producing some effect in the quantum system, such as their contribution leads to Casimir effect. So many things are there in the quantum realm or in quantum mechanics. Therefore, the playground of matter is different than the classical physics. That's why this is called quantum playground of matter. Okay, the set of rules are completely different than classical physics. Yes, this is not an abstract science. Just for interest, we are studying this, not like that. It is quite interesting, no doubt. Quantum mechanics, the phenomena observed in quantum mechanics is quite interesting. But physicists have already developed so many technologies using the principle of quantum mechanics, such as quantum computers. Quantum computing systems leverages the principle of quantum mechanics, like superposition and quantum entanglement. Then quantum dots are there. Quantum dots, this concept also uses the principle of quantum mechanics for imaging technology, for drug delivery system. Again, quantum cryptography, that technology has already been developed. Quantum cryptography, here for the purpose of cyber security, means for the purpose of unbreakable codes. This technology has been developed. So many technologies have already been developed, but there is a possibility of developing many technologies, new technologies. That's why quantum mechanics is so interesting. That means that's why this microscopic universe is so interesting. Many physicists are constantly making their contribution to this field. Many physicists are engaged in the research of such subjects or such phenomena all over the world. Anyway, so this was all about the topic microscopic universe, the quantum playground of matter. Okay, so this is the end of this video. Thank you for watching this video.